Hello, this is section 1.1 of Rosen's Discrete Mathematics and its Applications on Propositional Logic. Here are the topics covered in this section, and this video will only cover through the connectives negation, conjunction, and disjunction. In order to discuss propositional logic, we need to know what a proposition is, and here is a definition. A proposition is a declarative sentence that is either true or false. One thing to note that the bullet that you see here is actually itself a proposition according to this definition. And any definition is a proposition, and if it's properly constructed, it's going to be true. We can change the word proposition and replace it with the word question, and we get another proposition. But this one turns out to be false because a question is not a declarative sentence or a declarative sentence that is either true or false. Here are a few more examples of propositions. The moon is made of green cheese. Trenton is the capital of New Jersey. Toronto is the capital of Canada. 1 plus 0 is 1, and 0 plus 0 is 2. And 2 of these propositions are true, and 3 of them are false. I'll let you figure those out. Here are some examples of non-propositions. The first one is a command. The second one is a question. Neither of these are true or false. The next two are equations that have variables that whose value is not known or not set. And so we don't know whether those are true or false, so they are not propositions. Well, in order to use propositions in propositional logic, we use a shorthand to talk about propositions called propositional variables. And we will use these propositional variables to construct new propositions. So if you have a proposition, a declarative sentence, we can label it with a letter or usually a lowercase italics letter. And these, when we do this, we call these atomic propositions because we can't break them down any further if we've given them a variable designation. We talked about that propositions are true or false, and we could also say that they have a value, truth value. So if a proposition is true, we say that it has a truth value of true, or often designated with a capital T. It could also have a value, or sometimes called a truth value of false, designated with a capital F. And now if we have some atomic propositions or other propositions, we can construct new ones by linking them together using connectives. And there are 5 connectives that we will consider in this section. Negation with its symbol with a dash with a downward tick. Conjunction is sort of like an A, which is missing its crossbar. Disjunction is symbolized with a symbol that looks like a V, and then 2 more. The implication connective has a single directional arrow, usually facing from left to, usually pointing to the right from the left. And then the 5th one is a biconditional, which is the arrow that points in both directions. All right, so how do we use these to create compound propositions? We'll talk about negation first. You can see that all we do with negation is we'll take an atomic proposition P and we'll put the negation symbol in front of it. So this would be read, the negation of a proposition P is denoted by not P, where that symbol is read as not. And this has a truth table. In the truth table, we have the values of the atomic propositions, all possible atomic propositions, and then the values of the compound propositions that would follow. So if P has a truth value of true, then not P would have a truth value of false. If P has a truth value of false, then not P would have a truth value of true. All right, if P is the Earth is round, then not P states that it is not the case that the Earth is round, or more simply, that the Earth is not round. It is often convenient to use the phrase, it is not the case that, because that is an easy way to negate a proposition, but sometimes it's simpler just to insert not in the proper place. All right, so that's negation. It only has one proposition tied to it. The conjunction has two. So here we have conjunction of propositions. P and Q is denoted P and Q. And so whenever we read the word, whenever we see the symbol for conjunction, we think and. And that it helps because the A is sort of shaped a little bit like the connector for the compound, for the conjunction connector. And here is the truth table for the conjunction operator, the conjunction connector. Since we have two atomic propositions in the conjunction, we have to have a larger truth table to capture all possible values of P and Q. So P and Q can be true, 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 false, false, true, and false, false. So the table is a little bit larger. And the conjunction value for those values is, it is only true when P and Q are true. And if P and Q aren't both true, then the conjunction of P and Q is false. Here's an example. I've got P is the propositional variable for I am at home. Q is the propositional variable for it is raining. Then P conjoined with Q denotes I am at home and it is raining. So we could say P conjoined with Q or P and Q. Disjunction will be like or. Here's the use of it. The disjunction of propositions P and Q is denoted by this P disjoined with Q, and you could read it as P or Q. And in this case, it has a truth table, same values for all possible values of P and Q, but this time the truth table is different. P disjoined with Q is true whenever either P or Q is true, or both. And only when they're both false is P or Q false. Again, if P is I am at home and Q is it is raining, then P disjoined with Q or P or Q means I am at home or it is raining. And then one way to think about this is that you put in your head or both. So only one of them has to be true, but it's okay if both of them are true. Now this gives rise to an issue that happens in the English language. What is the use of the word or? So that's what we're talking about, is the use of the word or. It has two meanings, and for the disjunction, it has this first meaning. It's called an inclusive or. Here we have a statement which is a prerequisite for a higher level class. Students must have taken Computer Science 202 or Math 120. But if they've taken both of those, it's still okay for them to take the higher level class. So it's either they've taken 202 or 120 or both. On the other hand, the exclusive or is something we encounter in the English language as well. If you go to a restaurant and soup or salad come with a meal, you can't usually expect to get both soup and salad. It's one or the other. We have a truth table for the exclusive or, which is symbolized by this circle with a plus in it. And it is going to be, here's the possible values for P and Q, and P XOR Q is how we pronounce that, is only going to be true when P and Q have different values. It'll be false if they both have the same value, whether that's true or false. And this ends this video segment. We'll pick up with implication next.